All right. Welcome all to the Alta 2024 Summer Webinar Series, or I guess just Alta 2024 Webinar Series. We're really excited today to have Dr. Michael Pope from the University of Arkansas come to talk to us about the economics of potassium fertilizer applications and recommendations. This is a Alta first FRST joint webinar, and hopefully we'll be able to hear some more about that as we move forward with the webinar series. So with that, Michael, I'll hand it off to you.
Great, thank you. Thank you for inviting me. I'm going to go ahead and share my screen. Everybody, you can go ahead and can you see the slide deck?
Yeah, we can see it pretty good.
Okay, great. So I will start my presentation mode here. And as Corey Lacey had indicated, I am going to talk about economics of K Fertilizer. I'm an agricultural economist, but I've been working quite a bit with Dr. Nathan Slayton, Dr. Jerson Drescher, Dr. Trent Roberts here at the University of Arkansas. There's also some decision tools that I have on my website, and those I've collaborated with Dr. Purcell and Dr. Montserrat Salmaron and various other people. So there's a lot more here than just I, and also a bunch of graduate students. So this is the website that I have up, and today I'm going to talk about the potash rate calculator. And you can see, can you see my mouse? I hope. You can see that I got the 0060 in there, and so there's a potash rate calculator. And I'm also going to be talking a little bit about SoyMap, which is a soybean maturity group analysis and planning tool that gives us indications for yield expectations by planting date across different locations in the Mid-South, reaching all the way up to Carbondale, Illinois. So, and down to Texas and Baton Rouge, Louisiana. So that's the website. And now let's talk about potash. So I gave an extension talk this spring, and we were discussing potash fertilizer. And so as an economist, we look at the potash fertilizer cost and say to ourselves, well, how important is that rascal compared to revenue? And these are the 2023 soybean enterprise budgets for irrigated Roundup Ready soybeans in Arkansas. They were put up sometime in the fall. So $816 worth of revenue on a 60 bushel yield target. And then here we got potash fertilizer, 100 pounds at 0060, so 60 pounds of P2O5 per acre at a cost of $41.50. And you say, well, maybe I could have lived with a little bit less fertilizer, or maybe I should have put on more. And all of a sudden, this number right here takes on larger meaning relative to the amount of revenue that you're expecting. And I don't think anyone's expecting $13.60 beans at this point, because they're trading right around $11.50 right now. So the price of the crop and the cost of the fertilizer is gonna come down a bunch, and we'll talk about that. Those should all impact how much fertilizer we want to put on. However, current extension recommendations are based on a build and maintain philosophy. And so depending on what your soil test values are for potassium in soybeans, and I'm going to talk about soybeans today a bunch, you would be applying 160 to 180 pounds of K2O per acre. The budget said 60, so they were probably assuming that the STK level was in the medium range, and that's where the 60 pounds comes from. But if you're in the 61 to 90, then you double that, and 5% of revenue for that cost item turns into 10%, and so on and so forth. So to make that a little bit easier for producers, Dr. Slayton and Roberts and Dr. Drescher, we worked on looking at fertilizer response trials and created a relative yield index that would capture the yield response to K fertilizer based on a yield target for the beans. And I'll talk a little bit about the yield target here in a bit. That is then subject to the soybean price that you expect to get and what the cost of fertilizer is at the time that you're making your decision on whether to put on fertilizer or not and how much. And so you see in the bottom there a graph that gives a yield response curve from anywhere from 0 pounds of K2O per acre up to 175, 180 pounds. And then there's the soybean yield that is indexed to that 75 bushels per acre. And so you see a yield response and you say, well, my field might have plus or minus 10 STK across it. And we can talk about that here a little bit later, but these are the yield response curves for those bounds. These dots are actual yield observations from about 15 years of research trials for that soil test K range. And then you figure out where the economic optimum is. And in this particular case, it says to put on 104 pounds of K2O per acre. And compared to 0 pounds of K2O, you would be making an extra $71 an acre. And that is accounting for a $7.50 application charge for the equipment and labor and fuel and so on. The VRT recommendation for that parts per million recommendation is 116. It does not take soybean price or fertilizer cost into consideration. And so compared to the profit maximizing rate at that soybean price and potash cost, you're looking at making $1.12 more compared to the VRT recommendation, which is different from those categorical current extension rate recommendations I talked about a minute ago. So how do you determine the profit maximizing fertilizer rate? So let's imagine you're at the bottom end of this curve, and let's assume that we get an extra bushel per acre for each pound of K2O that you're applying. Now, that's much steeper than what's on this curve right there, but if I could get an extra bushel of soybeans for a pound of fertilizer, I would gain $13.60 in terms of revenue, and it would cost me 69 cents to put that on. So should I do it? And I guess the net effect is 13.60 minus 69 cents. You're gaining about close to $13 for that extra pound of K2O. And you say, well, yeah, I'm gonna do that. And then you see that the slope flattens. So you might get up to a half pound or half bushel per acre. And you say, well, I can't do math in my head, about $7 per acre more, 60 cents, keep going until you reach the point where the extra revenue that you get from putting on an extra pound of fertilizer is equal to the cost of that fertilizer. And that is the profit maximizing rate. And so that profit maximizing rate is a function of the soybean price, the fertilizer cost, the yield target, and the STK that you have in the soil. And so on the next slide, I show a situation where the initial soil test K is 110 parts per million. You see the curve is much flatter. If the curve is much flatter, then the slope drops off faster, or it's just flatter, and that means that you put on less fertilizer based on just STK, same yield target, same price, and same cost. And so, as I already alluded to, I hope that's all clear. Any questions so far? Okay. So, as I already alluded to, soybean prices are not the same. And in fact, I checked this morning and we're at 11.55 in 2024. And at the same time, our potash fertilizer prices are not the same either. And so I checked fertilizer prices this morning. And I think Illinois Farm Doc had a presentation where they're saying in March of this year, we're at 645 a ton. If you look at spot prices in the Gulf, those numbers are different, but what are farmers paying? You put in what you expect to pay into the tool, and then you get your answer. So that's kind of nice, but at the same time, you have to come up with some kind of yield expectation. And the yield expectation that we say is what's the, if everything is right, what's the maximum, or what's the yield potential of the field. And to that end, there's a tool on my website called Soy Map, and you can put in a different location. The last time I gave this talk, I was near Marianna, Arkansas. You can put in loamy soils or clay soils. Then you can determine what week that you want to plant in. And then you can compare different maturity groups of soybeans. And when you click on the yield and planting date comparison, it will give you this graph. And so for the planting date that I picked in Marianna, Arkansas, 4 to 4 4s versus 4 5 to 4 9s, we see that the 4 5 to 4 9s tend to have greater yield potential, because this yield on that side, and that likelihood of attaining that yield is on this axis. So your 100% likelihood that you're going to make less than 87 bushels with MG4s, 4.5s, and it's slightly less than that. So we want curves that are further to the right, and curves that are steeper, because that means there's less risk in them. So that's one thing to look at. And so 75 bushels was the yield target that I picked for the potash rate calculator. But it depends on what maturity group you're growing and what week you're planting in. And so here are the yields, along with the standard deviation around the yields for those same different maturity groups from 30 years of simulated soy grow data that were calibrated across 10 locations in the Mid-South, ranging from what I say Baton Rouge to all the way to Carbondale, Illinois, and east and west. I'd have to think about it, but you can go out on the website. What's nice about this tool also that it is that it gives you how much irrigation you need to put on. I know that's more of a thing for Arkansas and further south, where we're irrigating a bunch more compared to the Midwest. But the irrigation cost obviously probably impacts your decision as well. And again, that's impacted by planting date. And then another reason why I put this presentation up, or put this slide deck up, is that the tool also gives you expected flowering days, or day of first flower, or R1 stage. And you see the differences by, for that particular planting date, you see when those soybeans are going to flower. And that's important, because there's some more research that Dr. Roberts, Dr. Slayton, I don't know who else is doing, where I had a grad student of Dr. Roberts talk to me about in-season K application on the basis of tissue leaf K analysis. And that's most effective when you apply that 15 to 30 days after R1. And so if you're thinking about going a sufficiency approach or a profit maximizing fertilizer rate, and it's slower than the build and maintain number, then people say, well, maybe that's a little bit too risky for my blood. And what are the ways to maybe then address a lower rate that you might have picked with the profit maximizing K rate, and finding some perhaps hidden hunger in soybeans, then you might be able to address some of that hidden hunger with an in-season K application on the basis of leaf K tissue analysis. Now, the way I was told that that's done is that a producer or a crop consultant will walk through the field and grab some leaf samples, ship it off, get some answers, and then based on leaf K tissue results, you go ahead and make another pass of K if you think there's hidden hunger. And the numbers that I've seen so far suggest that that can be quite a profitable thing to do. But again, my mind should be based on crop price and fertilizer costs. But I mentioned this just to say that there's more research coming down the pike on that. The next thing that you got to be thinking about is, and my slide deck isn't moving. There we go. So I might bump ahead a little further here. I worked with Dr. Ponce at University of Arkansas because she's a precision ag person, and she has been sampling a whole bunch of fields for K. And so I've got soil maps for a number of fields, and I'm going to talk about the Lone Oak field because it's near Lone Oak. It's a 60-acre field, and you can see the shape of the field here. And so we sampled it a little less than an acre per sample. So 65 samples on a 60-acre field. And you see all those dots that represent the STK numbers. And then we map those out with inverse distance weighting using ArcGIS and came up with a soil map in a 60-foot by 60-foot grid. The 60-foot by 60-foot grid was chosen because I assumed an average width for an applicator around 60 feet without section control. And then I talked to some industry folks and said, how fast can you change the fertilizer rate as you move from grid to grid? And that's where the 60-foot by 60-foot grid came from. And as you interpolate across these soil samples, you'd say, okay, the soil conditions for STK seem to be a bit variable in this field. We got some hot spots in terms of K down here, and then there's some lighter STK and so on and so forth. And then we said, well, how many samples should I take on this field? Am I going to run out and do a sample every acre? That seems a little bit costly. And so we just systematically removed soil samples and reinterpolated to create different soil maps. So we went from 65 samples to 33 samples to 17 samples, and so on and so forth, all the way down to just 5 samples would be in excess of 10 acres per sample, and looked at the impact on, how the STK map changes. And one of the interesting things that you find is that some of the detail that you have over here that would drive the actual yields in the field sort of starts disappearing. But depending on, in this particular case, the choice of the 5th location, we can get quite a bit different soil test K maps, because you could pick one of these dots here and get higher STK levels than maybe what's in the surrounding area. So as you reduce the number of soil samples you take in the field, the weight on each sample takes on more importance, and what's the economic significance of that is basically the point that I want to make here as we move forward. Because these are rather large files, I pushed the next button on my presentation, but it's moving kind of slow on my computer. I don't know what's going on here. Here we go. So those are the same soil test K maps. And then if you remember the PRC tool, we then said, okay, based on the STK, if it's high, we tend to put on less fertilizer. If it's low, then we put on more fertilizer. Then we would have a K prescription map that with most information would look something like this. And then as you remove information, you start applying a little bit differently. And again, for the low soil sampling density map, you see a prescription map that's quite a bit different. And so, at least going maybe to this level or this level makes you feel more comfortable about where you're at in terms of soil sampling accuracy. What's the economics of that, though? Assuming I use this prescription map and applied it to, the field with this underlying STK information, and we get changes in what the average STK is for the field. And then you can say, okay, the average STK is what would drive my uniform rate recommendation. Or I could go for each grid and apply the profit maximizing rate in each grid. And so the first impact is that as you increase from the right side back to the left side, as you increase the number of soil samples, in this particular field, that tends to increase the average soil test K value in the field, and it also increases the standard deviation across the grids that we observe. And so if we increase the average STK, that means we have more K already available in the soil. We want to put on less of, this is in pounds of fertilizer, not in pounds of K2O. Then we can reduce the amount of profit maximizing K that we're going to go ahead and put on the field. And when we compare the K star or the profit maximizing K rate with the 65 soil samples to the one with just 5 soil samples, we see that we put on less with more information. And for the UK rate, we also put on less because the average moves in the same direction. But for the uniform rate, we're putting on a higher rate than we do for the K-star rate. So what we expect with VRT then in this particular case is that we would have some fertilizer cost savings. And then we have to still think about, well, what's the impact on yield and what's the impact on profitability? And so those K-star rates were based in this particular, for this particular field, were based on the 10-year soybean price of 10.82 per bushel and a fertilizer 10-year average fertilizer cost of $494 per ton. We took those numbers off of USDA NAS for the soybean price and off of the Mississippi State Budget Generator costs for muriate of potash or 0060. So in terms of yields then, again, by soil sampling strategy, taking, again, low numbers, and I didn't do the 5A and 5B. I just picked one of those three at 5 soil samples or 10 to 12 acres per sample, and then all the way up to 65 samples. And we see that the yield impact with lesser fertilizer use because of the average STK situation we just talked about, the yield implications are very small. And it's a function of the average STK level in the soil. And we see relatively little standard deviation in bushels per acre across the individual grids for which we each estimated a yield. That is very small. And if you looked at that field, you wouldn't be able to tell a difference between whether you sampled 5 or 65 times, at least in my opinion. With the VRT and the same thing for the URT. And the URT yields relative to the VRT yields look nearly identical. And with the URT rate, we actually get a lesser spatial standard deviation across yields, across the grids and the field. In terms of fertilizer cost, the K-star rates or the profit maximizing fertilizer rates with VRT were lower than with the URT. In terms of dollars, though, you look at these numbers and you say, well, there's some fertilizer savings, but not a whole lot. And so when you combine the yield effects, yield times price minus the fertilizer cost, you do see that VRT does a little bit better than URT. But is there enough there to justify the cost or the added cost of soil sampling as you go from 5 soil samples to 65 soil samples? And when you look at those numbers, I think you will see that when you take this number and subtract $6, and then I also assumed a $2 per acre upcharge for VRT application compared to URT application, that URT wins and that URT wins and offers the best solution with just 5 soil samples for the 65-acre field. And you say, my gosh, that can't be right. You know, economists, you're coming up with something that's kind of crazy here. So I kind of want to put these results into a little bit of a different light. Nutrient matching, from what we saw, nutrient matching of the crop with what's available in the soil pays small dividends. We didn't see much of a yield improvement. We did see some fertilizer cost savings. And so we did see what we expected, an improvement with better nutrient matching. but the dollar impact was relatively small. At the same time, we assume that we're using, or that a soil sample costs us $5 in terms of fuel, labor, actually dealing with the numbers and using the numbers. That's our estimate is $5. But that $5 charge usually doesn't just get you information about K, it also gives you information about pH and a bunch of other soil parameters. And so we said, well, if you split the cost of soil sampling and the previous slide to something less, 2 ways or 3 ways, then that whole line can be divided by 2 or 3, and then all of a sudden, your soil sampling strategy may move towards grabbing some more samples. And as I already alluded to, with the points 5A, 5B, and 5C, your K prescription maps are quite a bit different. And so relying on just 5 samples on a 65-acre field is probably a bit misleading, because you're taking chances there in terms of knowing what's actually going on in the field. And so it probably would be smarter to go ahead and maybe sample at least 8 or 12 samples on that 65 acres. The VRT upcharge is subject to debate. If people have invested in VRT equipment, they're going to charge more for that VRT application than the URT application. If they don't have any URT applicators anymore, it's a moot point. And so I would say that $2 an acre difference may be actually smaller, and that $2 acre difference comes from what they report for the Mississippi state budgets. And then the difference in returns between URT and VRT are pretty small. These are dollars per acre. And if you're talking cents or $1 or $2 per acre, and you multiply that times 65 acres, you're talking less than $100 in some cases on this particular 65-acre field. But if you're farming 3,000 acres, a buck an acre still makes a difference. But perhaps you could satisfy a little bit of profit potential just to know a little bit more about what's going on in your field in terms of STK and what you might want to do. So the overall conclusions that I'd like to offer for this presentation, and I know I'm still a little bit early, and there's some extra stuff that I've got in here in terms of future research. But let's wrap up on this so far. It's important to consider the price of the crop and the cost of the fertilizer when you're making your fertilizer application rate choice, if you buy into this sufficiency approach. I showed difference in profit between the VRT recommendation and the profit maximizing one that were quite small, but you change the price of the crop and you change the price of the fertilizer and the yield potential, and you can get some much larger differences based on average STK in the soil. In-season adjustment may be worthwhile, but the cost of sampling may be high. That leaf tissue K analysis, walking through the field, grabbing a bunch of leaves, and then analyzing that for hidden hunger and K. If you grab a bunch of leaves across the entire field, are you getting spatially applicable results to make your decisions on? So maybe you have to do several passes, and then that sampling cost may actually be a little bit higher than what it takes to do soil samples. So there's issues there yet. Minimizing sampling locations can be misleading. That's the 5 samples per 65-acre field versus 8 or 12. And then, in my opinion, take advantage of VRT if the upchart between URT and VRT is small. And so this is obviously a lot to take in. You say, well, shoot, can you give us a demo of the PRC tool, because maybe our producers would adopt it if you can demonstrate how easy that might be. So let me go on the internet, and I probably have to stop sharing and reshare. Okay. And if you go to my website, I'm hoping this shows up on your screen now. I'm not seeing it
We're
on my
seeing your screen. Fine, Michael.
which the slide deck or the
The
internet?
Yeah, the University of Arkansas website.
Okay, great. Thank you. I'm gonna stop the slideshow here real quick, and that'll probably help me out. Okay. No, it's not helping me, but are you seeing the U of A website now?
Correct, we are. Decision
Okay, great.
support software.
Great. So here's the PRC tool. And I like to demo this because sometimes the computers throw a monkey wrench into things. So if you go to the PRC tool and then you download the most recent version of PRC, and then you update or look at that one. My computer's not the fastest anymore. I'm about to get a new one end of this week, in fact. There we go. What you'll get is you'll get one of those enable editing. Can you see the screen again? And I'm blind on my end.
Yep, we can see the Excel document.
Okay, great. So you need to enable the editing. And then it says because there's some macros in there, you also have to enable the content. And here we go. And so we're not talking about cotton, we're talking about soybeans. So here's that graph that I showed you all earlier in this presentation. And so we said what soybeans are 11.50 per bushel right now. And that modifies the graphic in terms of the recommendation. Fertilizer, Illinois numbers I saw this morning are at 6.45 a ton. And then let's not be so optimistic about the yield potential and maybe go to 60 bushel beans. And let's take the soil test K down to 60 parts per million to say that we're in the low end. And right now the tool says put on 109 pounds plus or minus 3 pounds of K2O per acre. The VRT extension recommendation is 140 pounds. You're putting on 109 on the basis of crop price. If the crop price is lower, you want to put on less. If the fertilizer cost is high, you want to put on less. If the fertilizer price is low, you want to put on more. Let's try that out. Let's make the fertilizer $450. And sure enough, we want to put on more. We're still under the 140. And if fertilizer price is higher, it goes down to 91. But I guess the question or the reason why we developed this tool is if you were to tell a producer, well, your fertilizer price is 900, used to be 450, how much less K fertilizer are you going to put on? I said, well, I'm going to put on less. How much? Well, this tool quantifies that, and that's the nice thing about it. So let's go back to the 645. And then in terms of soil test K variability within the field, we could also analyze what happens if you had portions in the field that had maybe higher soil test K. So we expect a flatter response curve or yield response and therefore lower fertilizer use. And sure enough, we're down to 65. The graph resets itself on the 60 bushel thing. So what do we say, 60? We're at 109. At 100, we're down to 65. And so if you go to 120, say, it says this yield curve is too flat, even though the recommendation is 22 pounds of K2O per acre. Don't put it on because the benefit's not large enough to cover the application cost. And so with that, I think I can open it up to questions, or I can go back to the slide presentation and talk about some of the other fields that we've looked at already. What's the pleasure of the audience? I want to hear some questions.
Move to questions, for sure. Let me, I'm gonna grab, I'm just gonna real quickly go through, share our PowerPoint. So I did want to share, that before we move into questions, I did want to share that Alta is promoting with this first survey. And there's a little bit of information there. You can hit that QR code. I want to invite people to hit the QR code and do this survey as part of the fertilizer recommendation support tool. The other thing I did want to highlight is that there are CEUs available for this presentation. And if you open your CCA app, you can hit that QR code to get those points for today, or you can send me an email and I will make sure that you get credit for attending the presentation today. But with that, let's definitely open it up for any kind of questions or anything like that. So let's see. I'm just opening my chat. So if anyone wants to go off mute, you feel free to ask a question. Otherwise, or put it in the chat and I'm happy to read it out loud. So I'm not seeing a whole bunch of people jumping in with questions. I'll kick it off, Michael. I am kind of curious as you go through the presentation today and you were talking about the specifically the potash rate tool. How applicable would you feel like that is to growers outside of Arkansas? Is that very dependent on Arkansas specific fertilizer or I guess fertility recommendations, or is that applicable or a usable tool outside? And I know we got Nathan and a couple people on here. If you want to, I don't know if we want to invite them to comment on that too. But
Yeah, I was almost gonna go ahead and punt that to Dr. Slayton, but I would say it's probably applicable to the types of soils and temperatures and growing conditions that we face in Arkansas, mostly because the experiment trials that created those dots on the spreadsheet. I'm going to share the screen again here real quick.
oh yeah, I'll stop sharing. Go ahead.
I'm going to go back to the tool. Those dots that are in that spreadsheet for different levels of STK are 4 observations that we have under Arkansas conditions. Now, rainfall, a bunch of other things impact things, but these are for irrigated soybeans. And you know, if you're growing dryland beans, and if you have different soils and different soil profiles, different rooting depths, you know, your yield response to K is going to be probably different in different locations.
Mike, this is Nathan, if you can hear me. Hopefully there's not a whole lot of road noise, but I would
Nathan,
say
we can
that
hear you well.
Sorry, Corey.
Oh, I just said we can hear you well.
Okay, great. So I think the correlation on our data is very similar to what has been found from research in the Midwest. And by that, I simply mean our soybeans respond to soil test K very similarly as what has been found in other states in the Midwest. The question is whether or not the rate response is the same. But, you know, I guess my argument there as to the fact that I think Dr. Pop's tool is worth looking at is simply that most fertilizer rates are not based upon a response curve. They're based upon equations for building soil test K and replacing K by crop removal. So most of us don't really even know what a sufficiency response curve looks like. And so with that, I would say this is fairly unique data that is certainly at least worth a comparative look, and maybe trying it at a spot or two.
No, I think that was a good response, and I appreciate that, Nathan. And I guess I would not to distract or not to move too far away from the presentation today, but I wonder if you or maybe Deanna could comment on, is there any intent to use this type of way of thinking about things within some of the first data that's already in place, or that you guys are putting together as part of the first project?
Yeah, so I would encourage anybody that's on here to go to the website and look at what we've got. At the end of this month, we will be officially releasing the correlation component of the first tool. The next step, which we're in the very preliminary phases right now of pulling the data together, and we have a committee of scientists prepared to start looking at the calibration. One of the things, just to echo, Corey's mention of the survey, one of the key components of that survey is, what do you, as either farmers, consultants, soil test lab personnel, agronomists, what do you want information-wise to go into your recommendations? So I would encourage you, if you have an opinion on that, go in and weigh in on that tool. But this is the type of information that I think that we're seeking, is how passionate is everybody to move from a purely agronomic, soil test based, here's your fertilizer rate, to developing fertilizer rates that include the economics of the commodity price and fertilizer cost, as well as soil sampling and analysis cost.
Thanks for that response, Nathan. That said, if we I'll leave it open for a minute here for any other questions. Feel free to put them in the chat or just come off mute. Otherwise, we'll wrap up here in a second. All right, Michael, I'd say we have a quiet bunch today. Maybe it's too close to lunchtime for people to ask questions.
Well, it might be that, or there are more important things to do at the moment, which is fine too. We are doing more work on updating the corn and cotton curves, and we are also in the throes of looking at, does URT or VRT pay off with different soil sampling densities across more fields. And so I have a little bit more there, but again, it looks like maybe today is not the day, and this stuff is a bit overwhelming all in one shot.
Yeah, for sure. And I think we appreciate that. We at Alta, I think we look forward to hearing more updates from your research, especially as it maybe expands into other states and things like that. So again, thank you very much for today's conversation, and appreciate everyone that was able to come on.
Yeah, thank you everyone for allowing me to give this presentation.